Hey everyone, welcome back, and thank you for joining us again in our next discussion of statistics. Heading into our first objective then, we need to know how to approximate the mean of a variable from grouped data. First, defining grouped data, that's data that's already been summarized for us in frequency distributions. The downside here is we cannot find the exact values of the mean or the standard deviation, and this is because we don't have the raw data, we only have the grouped data. Thus, we have to approximate these measures using the techniques discussed in the section. Now this is where the process gets a bit technical. You see formulas that we'll use in order to approximate the mean from both a population and a sample, but in case this is a bit daunting, we're going to use list operations again, similar to what we did when finding standard deviation of raw data. A big aspect that we need to know though is what the value x sub I represents now. X sub I is the midpoint or value of the ith class. This is a big deal. This is the most commonly forgotten aspect of grouped data, the fact that we need to be working with midpoints as opposed to lower or upper limits because we don't have the raw data. Now f sub I is the frequency of the ith class. To explain the math in the background a little bit, what we're doing is we're taking a bunch of products. We're taking the midpoint for each class, we're multiplying that by the frequency of each class, and then we're taking the sum of all those products. Once we have that sum, we are then dividing that sum by the sum of just the frequencies. Similar to finding the mean of raw data, where we add up all our values of the data and then divide by how many pieces of data we have, that's what the sum of the frequencies are. The sum of the frequencies would be how many pieces of data do we have. The difference in this case though is we don't have all the raw data. That's why we're initially multiplying all these midpoints by those frequencies. Make sure we realize in this notation though that f sub n, like we see in the formula, n refers to the number of classes as opposed to now the total number of observations. Also take note that we will have to do this by hand on an exam, along with knowing how to do it on the calculator, so we'll cover both aspects. Let's go ahead and jump into our first example then. We're told to approximate the mean of the following data, which represents the number of hours a sample of first-year students spent preparing for class each week. Well, first we're given the number of hours, but notice that we don't have the raw data again. Instead it's grouped. So they gave us classes like we've dealt with before. We have the class of 0, and then they break into the classes of 1 to 5, 6 to 10, etc. The reason why they throw a class value of 0 here in hours is because the frequency is 0. So that's why it's okay. And then where our classes start, our limits become consecutive going from 1 to 5, 6 to 10, etc. That means let's head into the table to show how we're going to find the mean step by step in a free response situation. Well, our first step would be to find all the midpoints. Remember, x sub I represents the midpoints, but that means we have to remember how to find the midpoints. Just to review a little bit, remember to find the midpoint, I have to add up consecutive lower class limits. So first we're looking at the classes of 1 to 5 and 6 to 10. The lower class limits would be 1 and 6. We take those values, add them up, and divide by 2. That gives us a midpoint of 3.5. That is your first value, that is x sub 1, the midpoint, that is 3.5. Now to get the next midpoint, again just to review, we could take 6 plus 11 and then divide by 2. Or we can notice that the class width would be 5. Therefore, we can just take a look at our 3.5, add 5 to that, and we have our next midpoint, that would be 8.5. Continuing that pattern, we can finish out the table, and we're all set with our midpoints. That means f sub I, we have to remember, are the frequencies. Our table of data gives us the frequencies for each class. Starting with our class of 1 to 5, we're just repeating those frequencies because we're going to put those into our calculator. Once we have that all set, we're ready to go into the calculator, just like when we worked with standard deviation with raw data. Setting this up first on our notes, we're going to put our midpoints into L1, and we're going to put the frequencies into L2. Then our products will go into L3, so we're going to define L3 to be L1 times L2. Heading over to our calculator then, I'm going to hit Stat and Edit, and I have my data in L1 and L2. Remember, my midpoints go in L1, and my frequencies go in L2. Now, like we said in the notes, we're going to define L3 like we've done previously, but this time we're going to define it as the product that is L1, and we're multiplying that by L2. Once you have that all set, go ahead and hit Enter. You'll get that list of products, and we could input that into our table. And now that we have our table completed, similar again to when we found standard deviation of raw data, we need to find the sum of our L3 in order to apply that to our formula. That is, remember to find our sample mean. That would be the sum of those products that we found, represented in our L3 right now, divided by the sum of our frequencies. Well, if we add up all our frequencies, we end up with 1,000, and if we add up L3, we end up with 14,750. Just showing the work in the notes, our sum of our products would be the sum of our L3 divided by the sum of L2, which would be our 14,750 divided by 1,000, and we have a mean value of our 14.75. And we've got our first approximated mean from group data. Heading into our next objective then, we're going to discuss weighted means. Now, weighted means are going to be very similar to what we just did with grouped means. To find weighted means, we simply multiply each value of the variable by its corresponding weight, and then we divide the sum by the sum of the weights, just like we did with the sum of the frequencies. Taking a look at the formula, we see it's the sum of Wi, the weight for each category, times x sub I, the value of each category, just like working with grouped data, where we took the frequency f sub I and multiplied it by the value x sub I. So very similar to our previous discussion, now we're just working with a different context. Let's go ahead and jump into our example then. In our example, we're told that Bob goes to the By the Way nut store and creates his own bridge mix. He combines 1 pound of raisins, 2 pounds of chocolate covered peanuts, and 1.5 pounds of cashews. Then we're told the raisins cost $1.25 per pound. This is our first value of a category. So we established the category of raisins, and now we have a value that is a $1.25. Next, the chocolate covered peanuts cost $3.25 per pound, which creates the next category for us. And finally, cashews cost $5.40 per pound. Of course, the question asks, what is the cost per pound of this mix? That's why it's a weighted mean. We have different weights for each category and different values for each category, and we need to bring all these together to find a mean cost. So first, let's just gather some data. We'll have the prices of each category here, where we just said $1.25 for raisins, $3.25 for peanuts, and cashews at $5.40. And then gathering the weights for each category, we had 1 pound of raisins, 2 pounds of peanuts, and 1.5 pounds of cashews. This means we're all ready to go ahead and find our weighted mean. As we saw in our formula, to find our weighted mean, we know we need to take the sum of the products divided by the sum of the weights. Notice I'm writing it as x sub I times w sub I, as opposed to the way our textbook presents it, where w is first. I'm writing x first because when we did group data, we said x sub I and then f sub I, so it feels a little more natural to me. Filling in our formula then, we have the sum of our products in the numerator and the sum of the weights in the denominator. Make sure you're careful. If you put all this in your calculator at the same time, you need to put parentheses around each of these, the numerator and the denominator. If you finish up that little math, we end up with a mean of a 3.52. That is, what is the cost per pound of this mix? It's $3.52 per pound. And we're all set in terms of doing this by hand. Let's go ahead and chat real quick about how to do this in your calculator. It ends up being pretty easy. What we're going to say is let's put the values in L1, and we're going to say let's put the weights of each category into L2. Once we have our data in L1 and L2, we could run the 1var stats program again, and like we've done before, we need to do 1var stats, but now this time we do L1 comma L2, again making sure you're careful to put the weights in L2, because it will divide by the values of L2, just like we did over here by hand. If you do it in your calculator, we should end up with an x bar of a 352 again, and we're all set finding the weighted means using the calculator and by hand.